Assalamu alaikum. Okay, here we have a ball is ejected from a tube at this velocity horizontally 8 meters per second, and the question says find the equation of the path. So what this path looks like. Looks like parabolic, right? But anyway, we need to confirm that. And then find the ball's velocity and normal and tangential components of acceleration at this time, 0.25 second. So it looks like I need to find also an and at. Right, now to start with, let me make something here clear. This ball here, since it is ejected this way, right, the only acceleration the ball is experiencing is the g, which is 9.81. There is no acceleration in the horizontal direction here, right? So this is like similar to the projectile motion, right? So now I can here make this, say ay simply is g, which is 9.81 meter per second square, and there is no acceleration in the x direction, right? So it means now this velocity here in the x direction will remain the same. The only thing that will change is the velocity in the vertical direction. Okay, so now since we have constant acceleration, we can use the kinematics relation with constant acceleration. So we can use this y equal v naught y t minus half g t squared. Remember, we can only use this relation and the subsequent relations only when we have constant acceleration, right? So now we have zero velocity in the y direction initially, so this term here is 0. So now just let us cross that. So now we will end up having, replacing g by 9.81, we'll have negative 4.905 t squared, right? So this is now my y. But we want to find this as a function of x. So now somehow let us look for a relation so that we can relate t with the x. Also vx times the time, right? And my initial position is here, x is 0 and y is 0. So this is here 0. So we can say we can cross that as well. And we will have, replacing vx by 8, at. So from here, t simply is x over 8. Now we can replace this back into this equation here, into the y, and I'll get something like this. We'll get y equal negative 0.07664. Okay, maybe we don't have to write 4, but that's fine, x squared. So now that confirms that our intuition, it is a parabolic curve, right? The negative sign means it's concave down. Okay, so now we have found this, so we are good now. Now next, find the ball's velocity. How to do that? Now remember what we said. We said that this velocity will be constant in the horizontal direction. The only velocity that will change is the vertical direction. So initially here we have no velocity in the vertical direction, but now due to the acceleration to start to change. So we'll have something here. Okay, now to find this, I have my ball here, right? So I'm having something like this. That's Vx here, right? And that's Vy, okay? And this is the magnitude of this velocity we want to find. Now, of course, I can find this Vy also using one of the constant acceleration formulas, right? I can use this. I can use Vy equal V naught y minus gt, and V naught is 0. And now I just replace these numbers, negative 9.81. We want to find this at, remember, at 0.25, so times 0.25. Okay, now I get the answer here, negative 2.45 right? Maybe almost 3, okay, meter per second. Now this is my velocity in the y. So now since we have this velocity in the y, I can simply find, this question says find the ball's velocity. So they are really asking for the magnitude, right? So I want to find this one here. So we can simply plug it into our formulas here. So I have v equal vx square plus vy square, right? So putting these numbers, I get the answer to 3 significant figures, 8.37, okay, meter per second. Okay, so this answers the velocity. Now, what about this? What about the normal and tangential components of acceleration? Now, we have here to be careful about, first of all, we need to establish our t and n axis, right? Okay, now to do this, I'm going to say, this is the ball, right? Here. So my normal axis, I mean my normal axis somewhere here. Okay, it's toward the curvature, and this curve is concave down. Okay, so that's my end. Okay, I think I wrote by mistake t, so that's my end. Right now, t is just tangent to the path, right? So this is my t here. Okay, and now my axis given in the question, this is the x-axis, and this is the y-axis. Okay, and now see the following. Since we have said from the very beginning that this is the only acceleration we have, right? Now my acceleration here in the y direction, let me do it in another color, is here. So this is my a, right? Now look at this here. N and t are components of a, right? So we just need to find these angles, right? Now let us try to find this angle here, the angle here, this one. So let me call this angle theta. Now to find this angle, look at this here. This angle is the angle that both components of velocities here, Vx and Vy, are making with the magnitude, right? So this is the same as this one here, theta. And since we have Vy and Vx, I can just say theta simply is tan inverse of the y component over the x component, right? So the y component of the velocity, which is here, okay, of course we take the absolute value, right? 2.453, okay, over 8. Okay, I got here the angle almost 17 degrees. Okay, so now that's my theta, right? Okay, now what would be this angle here? This angle also would be 17. So this angle is also theta, right? Now if you try to rotate this, both of these axes, the more I rotate this, the bigger this will get, right? So both angles here are the same. Right now, so we have here, in terms of the n and t components, let me draw it here one more time. I have the n axis here, and that is my tangential axis. So t and n, right? And here is the a, right? Which is simply 9.81, right? And this angle here, we said it's the same with 17 as well. So now simply what will be n? An, the normal components of acceleration. So here an simply would be just 9.81 cos 17, right? And now here, if you do the calculations, I got 9.5 or 9.38, okay, meter per second square. And 80 would be simply 9.81 sine 17. Okay, and here uh, I got 2.88. 2.8 here, just 2.88 meter per second square. Okay, so this answers our question. Okay, I hope you find this video useful. If yes, please share and like the video, and let us know in the comments if you have any inquiry or question or any further suggestion for improvement. Thank you very much, and wishing you all good luck.